Okay, so the best way to understand implicit differentiation is just keep diving into examples. So the example I'm going to do here is a lot like example number or problem number 4 in your book. Okay, so we're going to find dy dx again, and this time we're going to find it for x squared equals x minus y over x plus y. Okay, so this is the same process we did last time, just a lot more involved. Okay, so the first step is to take the derivative of both sides. So I'm going to take the derivative of the left side, and then I'm going to take the derivative of the right side. Okay, the derivative of x squared then is pretty straightforward. This, on the other hand, is going to use the good old quotient rule. Okay, this is where it gets fun. Okay, so we're going to take the derivative of that. So I'm going to take the derivative of the left, which is just 2x. All right, so this gets especially interesting because we're differentiating with respect to x, but we have y in this problem. So quotient rule says take x plus y, square it, then take x plus y, and then we're going to multiply times this derivative, okay? Well, the derivative of x is x. Meanwhile, the derivative of y is -1, but it's dy dx that needs to go in here because I'm differentiating y with respect to x, okay? So that's the first part of the rule. Then I'm going to subtract, okay? It was denominator squared times the derivative of the top. So now I'm going to take the top times the derivative of the bottom. The derivative of the bottom is going to be derivative of x is 1, but the derivative of y is 1, but we need a dy dx. Okay, so now this is a big mess, okay? We know that we want to solve for dy dx, so we got to start cleaning up the algebra here. That's why I said implicit differentiation has a lot of algebra in it. Okay, so the left-hand side, I'm going to multiply everything out. I've got 2x is going to equal. If I FOIL this out, or double distributive property, I get x plus, actually, I'm going to delete that x minus there. I'm going to do x, x minus x dy dx. And now I'm going to distribute the y, so that's going to give me plus y, and then plus a minus y dy dx. Okay, minus, okay, I'm going to put this whole thing in parentheses. When I multiply this out, it's going to give me x. Then I'm going to go x times dy dx. And then minus y times 1 is going to give me minus y. Minus y times this is going to give me minus y dy dx. And that is all over x plus y squared. Okay, so the end result here, let's see, let's just bring this right-hand side over and multiply both sides. So that's going to give me 2x times x plus y squared, which is going to equal x minus x dy dx plus y minus y dy dx. Okay, now I'm going to distribute out the negative. So it's going to give me negative x minus x dy dx plus y plus y dy dx. Okay, so I see several dy dx's. I'm going to see what can cancel here. So I definitely see that this x and this x cancel. I've got dy dx, dy. I want to combine all of those. So let's see how we can combine those things. So over here is going to say 2x times x plus y all squared is going to equal. I've got a y plus a y, which makes 2y. And then I have an x and an x, which makes negative 2x dy dx. And Does that combine everything? Do the y's cancel? Okay, so I can cancel those out too. So negative y dy cancels with plus y dy dx. Okay, so a little bit cleaner now. So next step, I'm going to subtract 2y over to here. So I've got 2x. I've got 2x times x plus y all squared minus 2y equals negative 2x dy dx. Okay, so in the next step, we are going to divide everything by negative 2x. So I'm going to divide this by negative 2x, and I'm going to divide this by negative 2x. So that is going to result in dy dx is equal to 2x times x plus y squared minus 2y over negative 2x. Okay, we've isolated the dy dx, which is that last, when we did the proof before, that's what we need to do is the problem before we had to show dy dx and isolate it. The only thing I can do to simplify this a little bit is to divide everything by 2. So I've got dy dx. So I've got a 2 here, here, and here. So I can just say that that's going to be x times x plus y squared minus y all over negative 2. No, that's not right. Over negative x is what I want. All over negative x. Okay, and now I can kind of split this into two pieces. So I can say dy dx. What I'm going to do is split it. I'm going to take, divide it this way, and I'm going to split it over this way. Okay, so when I do that, I'm left with x over x plus y all squared over x minus y over negative x. Okay, so then that's going to become dy dx, and this should have been a negative x here. Dy dx is going to equal, okay, negative negative is going to become positive, so I can write it as y over x first. And then I'm going to subtract. These x's here are going to cancel. So then I'm left with x's cancel. I have the negative out front of x plus y squared. Okay, so that's again how to use implicit differentiation. In the next example, we'll start finding the slope, the equation of the tangent line.